All right, real quick review. You guys are actually going to do this for me. I'm going to have a point A. Point A. Yep, point A. Okay. Dan, you want to give me that point A for your classmates? Anyone you want? No. No. Give me a negative one, too. One of them coordinates got to be negative. All right, here we go, everybody. 6, -4. Here's what I would like you to do to that coordinate every time. Ready? I'd like you to do this first. Tell me what A prime is. Go back, always go back to the original and perform this. I want to see what these new coordinates are. And then do this. And then there you go. So what is A prime every time? And again, please always use 6, -4. Do not use a previous answer. So you can graph it if it helps you. All right, I just want to know the new coordinate. So I'll give you a couple minutes. And yes, I specifically picked 10 so it would not fit on your graph. Just don't want you to forget about this. Ready to go here. Y-axis first. Just give me the new point over the y-axis. 25. Y-axis. -6, -4. Everyone good with that one? -6, -4. Nice job. All good? Okay, how about y equals x? Had to remember the rule for that one. Y equals x. 16. 9. Y equals x. All right. The rule, everybody, was just flip the coordinates. Don't touch signs. Oh, this is fun. How about, x equals 10. 25. 6, 20, 24. X equals 10. What type of line? Vertical line, right, everybody? Not horizontal, vertical line. So 1, if it's a vertical line.
A prime is 14, -4.
14, -4, yes. Hey, can we all handle that? Doesn't fit on the graph and we can't count. All right, take a look. 6 to 10, 4 units. So you go 4 units in the other direction from 10, you got to be at 14. Y coordinate doesn't change. And then finally, y equals negative x. Just remember the rule for that one. 5. 4, negative 6. Everyone, what's the rule for y equals negative x? Flip and change the signs. All right, we all good? Just wanted to go over all these again. And then also remember you're responsible for y equals 2x plus 3. We just don't have time to review that again. All right, flipping it over, that type of line. All good. Reflections are done. 3 days, done now. Whew, thankfully. You ready for your next rigid motion? We did a lot of flipping in the last 3 days. Now it's time to slide. Now it is time to slide. Translation. We're going to slide left, right, up, and down. And at the end of this notes today, you'll see one of my top 5 problems. Don't cheat. All right. How do you know a reflection's happening? What was our symbol? I just had a whole bunch of them up there. Lowercase r. All right. Translation, actually, there's 3 different ways it could happen. All right. 3 different notations. First notation is called a function notation. Here's what it looks like. It says, hey, take any random point, x, y, take any random point, arrow, here's what you're going to do to it. X minus 1, y plus 2. That's called function notation, and that is telling me I'm doing a translation. Here's why. Where am I moving this point if I'm going minus 1? Oh, boy. X-axis. Think about the x-axis. You can only travel left and right. So this is going left 1, up 2. So I'm sliding left 1, up 2 to this point. All right? That's function notation. It's going to tell you exactly what to do with the x, what to do with the y. Vector notation pretty much just gets right after it. -2, 5 with the little inequalities there around it. That's called vector notation. Where am I going to move this point? Left 2, up 5. Left 2, up 5. That's called vector notation. Very simple, right to the point. Then you have other notation, which it doesn't have a name for, so we just called it other notation. This uses a letter for translation. It's T, uppercase T. And yes, that's how I roll with the fangs. I don't care if you do it or not. That's how I roll with my uppercase T with the fangs. All right? And then as the subscript, it will have where you're going to move. So 4, 3. That's another way, a third way you'll see a translation. So where am I going to move my point? Right 4, up 3. So I have function notation that says it's a translation, vector notation, and then this other notation with the capital T. All 3 ways you could see, or I could have you write. Okay? I could leave your answer in vector notation, leave your answer in function notation. All right. How do I know an actual translation's going on? Take a look at my 2 squares up here. A, B, C, D, A prime, B prime, C prime, D prime. Is this a translation or not? Well, I don't know yet. We'll have to test. Everyone, tell me what you do to go from A to A prime. And remember, we're testing a translation, so don't tell me flip over this or turn it. All right, tell me up, down, right, left, how many right now? All right, so A to A prime. Sliding it. Oh boy, we got to learn our directions. What do I do to go from A to A prime? Right 6, down 3. If this is truly a translation, I should do the same directions on B, C, and D. Test it out. Do I go right 6, down 3 on all these bad boys to get to its image? Because if one goes right 5, down 3, no good. They all have to go right 6, down 3. And what are you guys noticing? Are all of them the same direction? Yes. All right. So this is a translation. All points move where? Again, move right 6, down 3. All right, right 6. They all have to move the same amount, everybody. All have to move the same amount. 3 out of 4 won't cut it. All right? All right, now let's actually move them around now. Let's actually move them around. Go ahead, graph triangle ABC. All right, now I'm asking you to translate it using vector notation. Using vector notation, -4, 1. Where are you going to go with points A, B, and C? Left 4, up 1. And yes, I know it doesn't say state the coordinates, but I would appreciate it if you told me what A prime, B prime, C prime were after you move them left 4, up 1. So go ahead and do that, and then move your triangle. Can I please have your new points? 9, can I please have your new points? All right, 1 for 1.
B prime -1.
Decent. Now finish.
C prime -5.
Thanks, Maggie. Great job. Any issues, vector notation? Next. Let's keep this train rolling then. Now you have that other notation with the capital T now. All right, so go ahead, graph triangle ABC. And then in the image under this other notation, I know it's a why do I take a look at part B real quick? How do I know this is a translation? Other than that's the notes we're doing today. It's a capital T. Take a look at the numbers underneath. What are you going to do to points A, B, and C? Right 3, down 1. Let's roll. Don't try to answer part C yet. Hey, let me know those coordinates. 8, let me know those coordinates. Come on, Colin.
For A prime, I got 0, 3.
Yeah, you did.
Oh.
Okay, great job. Great job. You were waiting for applause or what?
And then for B prime.
0, 3, column, baby. Yeah. Yeah, there you go. Good, good. There you go. See, I got you. I got you covered. Go ahead. B prime. See, all this, see, now ruined it. All the hype.
-2, -1. I mean, -1, -2.
Rattled. It's totally rattled, this kid now. Finisher.
And then for C prime, I got 1, 0.
There you go. Nice job. Nice job. Nope, 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 nope. Nope. Got his praise and then screwed it up. All right. Everybody good? Questions? All right, now we get to part C, and this is the brand new piece today. Actually draw the vector that defines it. Well, first thing is, what's a vector? Okay? What's a vector? It is a ray. Okay? It is a ray. I'm just going to show you an example one. It is a ray that shows the direction and the distance you moved. All right, so I need a ray drawn on this graph that shows me that you went right 3, down 1. All right, easiest way to do it. Didn't you move 3 points? Right 3, down 1? Make a ray. So ready? From A to A prime, B to B prime, C to C prime. I'm going to draw a ray that starts at A and the arrow ends at A prime. That vector right there is showing that you went right 3, down 1. Now, if you really want to be hardcore, do it somewhere else on the graph. Start at a random place and go down 3, right 1. And then draw that vector in. That's also acceptable. What? I'm allergic. I'm allergic. Stop. Done. We're done. 1, 2, 3, down 1. How about that? There we go. Yeah. All right. I never liked any of you anyway, okay? So it doesn't matter, all right? We all good there? All good? Bunch of comedians in here. I knew it, too. I knew it. I knew it. This couldn't get any worse, and I knew it was about to get worse. I knew it. I knew it. It was going to get worse. Anything else before we vote? Fade. Shatter. Curtains. Cubes. Slide to the right. Slide left. Star. Genie. Curls. Drop. And the pinwheels. All right, ready? We got to slide to the right, or Promethean Man. I got to go that way. All right, slide to the right, or Promethean Man. Everyone ready? Ooh, didn't even have the old flip. Didn't even have that one up. All right. I don't have another slide. I don't have an option. It would have been literally nothing. There's the fade. Here's what it would have been. Nothing. Okay. All right. All right. Good try. Good try. All right. Back to business. All right, number 4. A lot going on here. There's a translation, and that translation moved 3-3 to 6-1. So we'll find the rule in a second. Some translation moved 3-3 to 6-1. I want you to use that rule, use that translation, but now take a look. Find the pre-image. So this was where I ended, guys. 8-3 and 2-5. Where did I start using this rule? Well, first of all, let's get the rule down. I'll just throw it in vector notation right now. 3-3 to 6-1. What did I do? What did I slide? 3-3 to 6-1. I went +3, right 3, and down 2, so -2. So using this rule, on some point, I ended up at 8-3. What was that point I started at? That's for your job right now. I ended at 2-5. What point did I start out on? Pre-image. Which point you started with? Don't apply the rule to the point. This is where I ended. Got to know where I began. All right, going to need a couple studs here for this one. 21. All right, where did I start to end up at 8-3? 5-5 it is, yes. I started at 5-5, applied 3-2, and ended up at 8-3. How about part B? Where did I start for part B? 26. -1, -3. Good job, both of you. Nice job. -1, -3. All good there. And then the final one here. All right, going to the marching band. Any band camp kids in here? And what I mean by band camp is you play an instrument. Okay. Okay. Yeah. I call them band camp kids. Band camp. Yep. That's what I call it. All right. And it may seem like I'm just joking on those guys, but I actually have a lot of envy for them because my instrument experience was 5th grade baritone and it ended in 5th grade. So, all right. Yep. All right. That's where it ended. So I got a lot of respect for you guys. All right. Here we go. Also, in case you needed assistance, I put the little right, left, forward, backwards down there, all right, because I heard a lot of people say go down on the x-axis, so we added that in there, so that might be helpful. All right, describe the translation of trumpet line 1 to 2. I want it in function notation and in words. So as I go from position 1 to position 2, where did I go? Okay, don't yell anything out, just take a look. Also, I'm going to warn you, some people aren't even realizing it. Look at your X and Y axis, or look at your X axis and Y axis. I'm not going by ones. Going by twos. Be aware of that. I'm going by twos. So every unit is 2 units, not 1. So I would first start in words, all right? That's what I'm going to ask first. First start in words, how you're getting from 1 to 2, and then we'll put it in function notation. So from position 1 to position 2, how do you make them right on top of each other? In words, just describe to me what do I need to do to go from 1 to 2. 13, what do I have to do to go from 1 to 2? Left 12, that's it. Yep, left 12. All right, function notation. If you look back at the beginning, you're telling me X, Y becomes with the arrow. How do I say left 12? x minus 12, and is there anything I need to do with the y? I didn't go up or down. You can leave it y. You can put y plus 0, y minus 0, whatever floats your boat. All right, but just leave it as y because I didn't move. Good there? Last one. Now you're going from 1 to 3. How do I go from 1 to 3 but leave it in vector notation now? And if you can assume that if it's in the middle, it is a half. All right, half. It's right in the middle. All right, vector notation. How do I get from 1 to 3? 4. Hello, Emma. You had a couple more steps in there. The left, because remember, when you we're going 1 to 2, but to get there, I go over here and down. Right? So we went left 12. See that? And then from there, you would have went down. Okay, yeah, more on there.
Because I went like down.
What'd you do?
I went.
What'd you do? Or you don't want to tell me again? Sure. One more chance. Early going on a cruise. Maybe you're gonna. What? Too harsh? Poor Emma. Too harsh. You could take it, Emma. Right? You could. All right. There you go. All right. Didn't know if you were gonna jump ship today or what. You were a little nervous. We're gonna get a big flood here in town. You know. Like that's a shock now. Like that's a shock. Week 25. That's a shock in here. Questions? Okay. There we go. We're good for today.
Do you have a day where you roast everyone individually, just like one by one?
Nope.
Like the lab did everyone.